Okay, here we're going to do question 18 on page 31. And this deals with the area created with a tangent and two coordinate axes. The equation itself is y equals 1 over x. I'll just graph that now. And y equals 1 over x, we should be fairly familiar with that. It looks like, let's get my axes in. This just looks like this. And it looks like this. Now, where this question was placed in the textbook, oh, hold on a second, I'll draw in the tangent first. So the tangent was at the point AB, and for my write-up here, I'm going to be using B a number of times, so hopefully we can keep it straight here. So there's your tangent. So the area created, or the triangle created with the tangent and the two coordinate axes looks like this. And as we know, the area of a triangle is going to be base times height divided by 2. So there's the base, and there's the height. So by the end, we'll have we'll be able to discuss base times height over 2. Now, as I was going to say earlier, the context of this problem was that we are doing the slope of the tangent for first principles. So I'll just write it up over here. Instantaneous rate of change is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. So I'll just go through this real quick. It'll take a few steps, and while I'm writing this out, I'll just say I've got a cold right now, so apologies if I sort of snort hard in the microphone, or if I end up slipping out a cough here. Hopefully that doesn't happen. So I'm going to do my common denominator here, and I get this x minus x plus h over h. Apologies, I'm left-handed, so I'm going to try to not block my own writing too badly. So I'm going to expand up there, x minus x minus h over x times x plus h times 1 over h by invert, and multiply that denominator. So here's the, I'm going to simplify. I'll get x minus x, that's just going to be negative h. And I'm going to have, well, we're not going to expand that denominator, and then we'll have 1 over h. So the h's are going to cancel, and we'll be left with the limit as h goes to 0 of negative 1 over x times x plus h, which, as we can see, is when h goes to 0, that will be negative 1 over x squared. So just to put a bit of a formality on this, we'll call that f prime of x. There we go. F prime of x. And this equation is going to represent the slope of the tangent to any point on that curve. So what we're going to do is we're going to talk about this specifically at the point A. So for that, we'll talk about f prime of A. Let me just put that down here. F prime of A, that's going to be equal to negative 1 over a squared. So that will be the slope of the tangent to any point. So that is going to be very useful when we go ahead and do this up here. The next thing we'll talk about is f of a. So as we can see, the coordinate is ab, so f of a equals b. But since we're dealing with the equation y equals 1 over x, b will be equal to 1 over a. So that's sort of the first instance of many uses of b in this problem, but hopefully we can keep up. B is the base, and b is the y-intercept of this line, and b is also the y-coordinate of the point of tangency. It's but I should have probably thought that out a bit, but well, now we're there. So the y value is going to be 1 over a, and the slope of the tangent at that point will be negative 1 over a squared, and the x value for that point will just be a. So now I'll be able to simplify that and solve for b, which will give me the y-intercept. Yeah, that b right there is the y-intercept. And that would be the y-intercept for the tangent line regardless of what the value of a is. So whatever, if my value of a, well, for whatever value of a, the y-intercept of that line will be 2 over a, and that is an important thing to have. So now I can talk about what the tangent line, or the equation of the tangent line, is going to be for any point. So that'll be negative 1 over a squared x plus 2 over a. So that's the equation of the tangent at any point. So I'll need to know that, because now for that line, yeah, that line up there, okay, so for that line, I now want to know what the x and y intercepts are. So I'll start with the y-intercept. The y-intercept is 0, 2 over a. Okay, and now we'll find the x-intercept. So the x-intercept, we're going to set y equal to 0, and then we're going to solve for x. So what that means is I'm going to, I think I'll bring that negative 1 to the left-hand side of the equation, and that should be easier to deal with. So they'll bring the negative 1 over, so I'll have a squared, 1 over a squared x equals 2 over a. 2 over a. So I'm going to isolate x, but it looks like I'm going to run out of room on this paper here, so I'm just going to move that up. Go ahead. Just move that up as I get a bit more room down here. Hopefully I can finish this problem on the page. Okay, so if I multiply both sides by a squared, I'll get x equals 2a. So I now have my x-intercept, which is 2a, 0. So for the triangle that I had right at the very beginning of the problem, I now have a base and a height, because those were the x and y intercepts for my tangent line. So I've got my height, which is the y-intercept, or 2 over a. I've got my base, which is my x-intercept, or 2a. So now we can go right back and talk about the area, which is equal to base times height over 2, or 2a times 2 over a over 2. And I don't think I'm going to fit this on, but hopefully we can just see very quickly here that 2a times 2 over a, that's going to be equal to 4a over 2, which is just going to be equal to, all that cancels, and that is all going to be equal to 2.